So welcome to our September Physics Matter Colloquia series, focusing today on the African Light Source project. So where Professor Simon Connell will explain the momentum growth for this ambitious African light source. So we have the member of our panel. So today, we will have Sekasi Minkweka, who is from the US, so representing as well. So with Simon, the African light source, and from the FIP, so Joni Mela, from ICTP, and myself from the European Spallation Source in Sweden. So we represent the share line for the Forum of International Physics. And together, we want to create a flow of ideas which are both educational and interesting for your community. So we recall that Simon gave a nice introduction during the Spatial Forum in July. So as we were celebrating the origin of Sesame, with Professor Herman Winnick. So please visit our website and watch the podcast as well and the recording in order to have a better memory as well of this memorable moment. So we have created those websites, so you can visit them at your convenience and seeing all the different colloquium that were already every month representing this forum. So today, Simon Connell will evaluate and elaborate a bit more this African light source. So he's our guest, and he is in the Faculty of Engineering, and he's as well building the environment of the university at the University of Johannesburg. He has research interests in particles, nuclear, quantum and applied physics, nuclear energy, material science, high performance computing and innovation. So he's the past president of the South African Institute of Physics, and he's the founding member of the South African participation in the high energy physics at Atlas, at CERN. So he's also a user at the ESRF, in Grenoble, the European synchrotron facilities. So he has published over 170 papers in international journals, and he's also an Atlas author with over 600 Atlas papers. So he has numerous citations. There are many zeros, and he's interested in technology and innovation for competitive industry, so participating in peace application of nuclear technology. And he has also a project on the intelligent sensor-based sorting diamond in Kimberley. So he supports nuclear energy, both large-scale generation and also small moderator reactor. So he also works on the implementation of the roadmap towards the African light source. So he's the executive chair, and he's also on the steering committee developing the current community-driven, the African strategy for physics. And personally, I've met Simon, when we were organizing the very first African school on fundamental physics and application in South Africa in 2010, the ASP 2010. And so he launched as well. So the launching of this successful initiative for the African light source has been also an eye-opener and of many more initiatives. So it was also this African light source suggested and recalled by Professor Winnick in 2012 during the second edition of the ASP in Kumasi in Ghana. So we will today keep the question for the end, and we leave Professor Simon Connell to share his screen and give his presentation. And you can put as well your comment if you want on the question and answer. And we see that Professor Herman Winnick is now connecting. So welcome, Herman. So it's good to have you here. And we will have more possibility for forum interaction as well after his presentation. So Simon, then the floor is yours.
I want to thank you very, very much for that very, very kind introduction, Christine, and also for the opportunity to talk in the American physics series here. Physics Matters, that's great, and have the opportunity to let everyone learn more about the African light source. So this slides have too much information. I just want to say, imagine that you can download them somewhere, that the link can be provided if you want to check up on anything. So to start off, very briefly, I will cover some history and the motivation why, and look at some African science examples and tell you about our roadmap and different things that we are doing that are coming up. On this slide also, you will see some papers that have been written and also links to our website. So I wanted to start by saying Africa already has experience in large-scale research infrastructures. So this is the square kilometer array. And you see in this map down in the bottom, you see Africa is the host of one part of it. Also Australia is the host. And then in pink, you see other African countries who are also taking part. So quite a substantial footprint in Africa, and they presume it will grow. And it's an international project. So you see other regions in the world colored in. And why I want to mention it is the kernel of the square kilometer array, which will be in a desert in South Africa. It already exists and it's known as Meerkat. And this is a selection of science you can cast your eye over and see really exciting things. And I want to say it was built ahead of schedule, and there's a lot of innovation in, and it's a premier source of very, very impactful science now. And so when we think of Africa having an advanced light source or synchrotron, it's something that should be very, very natural to think about. I just have a few slides if you would like to be reminded what a synchrotron is. So I've chosen to show you Sesame, which is in Jordan in the Middle East, and it's an international one. So it's like the ESRF in that many, many countries participate in its governance. In that sense, it's also like the CERN of synchrotrons in a way, because CERN also has many, many participating countries. So this is really an international facility. And then, of course, you also recognize a tremendous role in science diplomacy. So that's something about a synchrotron. I also want to show you Sirius in Brazil. Why? Brazil is a third world country like all of the countries in Africa. And this amazing thing is the synchrotron in Brazil. You can see how big it is. You can also see how beautiful it is as architecture. And it's 90% local manufacture. And when you visit it, you actually become stunned at how established young people are as researchers in their very high standing. Is that you realize that the young people had the opportunity to step up and grow in their stature. It's really amazing and very, very inspiring to see. And conferences in the science areas covered by the synchrotron essentially can't be mobile anymore. They have to be hosted by very, very, very large venues. It has grown science in Brazil in such an outstanding way. And also want to point out the empty land around the synchrotron here, and that's on purpose because it's going to grow into a mega techno park. In Brazil already, there's evidence of how it has benefited local industry. It's not just science, it's also innovative industry. And then something that struck me very powerfully in COVID times, to the extent that on this montage of the Brazil light source, I put 2 COVID viruses. I mean, CERN shut down during the harsh lockdowns of COVID, but the beamlines that were doing bioscience of many synchrotrons around the world stayed open. In actual fact, we could view them as essential services. They unlocked the structure of the SARS-CoV-2 viruses. Pictures of it up there, the spike protein, and a zoom into molecules on the spike protein, so that one actually gets atomic density on billion atom molecules. And the idea is that from the function, you understand the function from the form. Okay, and so this was crucial. These pictures that we were getting from the synchrotrons, they are what identified targets for drugs, thereby leading to the medical interventions and the vaccines to happen so fast. And now we look at Africa's disease burden. You see listed there so many. Africa has a huge disease burden, especially big. And so this is when we would like to say Africa needs, just for this one picture, a synchrotron, so that it too participates in the search for vaccines. I just want to highlight that, because we couldn't properly address COVID unless each and every country had the same excellent access to vaccines. And if one country is too poor or doesn't have a science program, etc., doesn't have the vaccines at the right time, it then becomes a breeding ground for evolution of viruses to evade the vaccines elsewhere, and the whole world remains vulnerable. So we need the whole world to participate in science globally. I think COVID really showed us that, and it wasn't enough to benefit from intellectual property overseas. It took much longer to transfer the licenses and so on, and that was a big delay for Africa. So it's a message that African governments have got very, very strongly, is that we need African research as well. And it's not only us that needs it, it's the whole world. And again, this now is a light source in Spain. And you see the flying saucer shape in the very middle of the picture, but you see the enormous acreage of the technology park that's been set aside. And I think also this is very, very important. I wanted to highlight that light sources have been going in the rest of the world for so long. They're on what they call their fourth generation, and Africa doesn't yet have the first generation. You'll see why. Why is that such an important issue? So the light sources address so much science. You know, if you look at this picture, you just see medicine, then you see geosciences, and then you see biology and chemistry and so on, material sciences. And it's just absolutely amazing, and it accommodates academia and industry. So now with Africa, we don't like to say, oh, we want one too, you know, it's FOMO, fear of missing out. So this is our carefully drafted rationale why we want a light source, okay? So it starts with looking at African challenges. I already told you Africa's disease burden. That's just one example. It could be beneficiating Africa's minerals. It could be the paleo and archaeo heritage of Africa, which is being done by other countries, essentially, where Africa would like to participate strongly in understanding its own paleo and archaeo heritage. So those would be African challenges. Also energy. You can put all 17 sustainable development goals there if you want, but there will be aspects which are uniquely African. For example, I could say the AIDS virus is a different strain in Africa. It's much more virulent and it needs special treatment. So if Africa doesn't do the research here, who will? So this we call the African scientists, and from there, African challenges, from there, we identify the science that's going to address those challenges. And once we've identified the science, then we look at a research infrastructure that can support that science and then we get to the African light source. So I'm going to show you examples of this. And then another aspect that I want to point out, especially we learned it from Sesame, is that we must evolve to major African funding. So I'm sure there are people maybe who are on funding agencies in the audience, and we welcome funding from funding agencies, but ultimately Africa must do the major funding of the synchrotron. So this is our big job, to persuade African governments of this. Okay, Pan-Africanism, we want that. Obviously, you know, what has Sesame done for that? What has CERN done for that, for the world, is remarkable. So we want that science diplomacy to spearhead the Pan-Africanism, to build that, be an important part of that for our continent. Now, sometimes when you say African light source, then they imagine, oh, that's going to be in one place, like ESRF is in Grenoble, then other people don't benefit. But the Africa Union has a saying, I put it in blue there, leave no country behind. And this will be true. There will be not one country in Africa that does not benefit from the African light source. Why? Because there will be local or regional infrastructure that must improve everywhere in order to access the light source. Also, you can access the light source remotely. And even now, if an African travels, let's say, to Diamond in the UK, I'm just picking one, the time could be similar than if, let's say, a Polish person went to the same place. So, and just pointing out that the world's a big place for everyone. And in that sense, the African light source is not winner takes all. So we would like African governments to start participating in governance of research infrastructures. The square kilometer array is one example, but I'll mention others also. And then number 6 is what we really can do on a much lower budget. We're doing that now, is the African user-based development, particularly looking at the youth. And you see the different things that we're doing there. And then also, you know, just for completeness, I put socioeconomic benefits, but I just want to go to my very, very last point at the bottom, where I say that a 4th generation source has a figure of merit of 10,000 times better than the 3rd. That number, it's so remarkable, it's hard to believe. I'm going to show you just now why it's 10,000. But imagine you buy a new car, and then it's better in some things, better at Bluetooth connectivity, the navigation's more integrated, who knows what. Your new car is not 10,000 times better than your previous one. Maybe it's twice as good. So just keep in mind, the 4th generation clocks in on a figure of merit of 10,000 times better. And so when you think that Africa is not yet with its foot on the ladder, and the next step is 10,000 times better, that's part of the urgency. Why 10,000? So this is the detector technology that you see here in spatial resolution, time resolution. So 4 dimensions is getting better and better and better. And so people are using a number of 100 times better detector. You can take foster data and you can do 4D, as they call it. And then the emittance of the source has got better. So there's that very well-known picture on the right. It's just awe-inspiring, the improvement in the brilliance of the source. But going to the new technology, they call it hybrid multi-band achromat, and Herman will be very, very familiar with that. So that is a development in the guiding of the beam in the synchrotron, and that came with another 100. So when you take the beam is 100 times better, the detectors are 100 times better, you get to fourth generation synchrotrons 10,000 times better, to the extent that scientists have to relearn how are they going to use and deploy this incredible excellence. That's why, if you look at the map of synchrotrons in the world, you see many, but this shows the ones doing the major upgrades, and they're synchronizing them so that, not all synchrotrons go down at the same time. So this is what I find very interesting about this picture, is a synchrotron's not a thing of the past. It's just undergone conceptually this massive upgrade. I was also told, that we at the stage where young people who did their PhDs at synchrotrons are now, for example, in industry. And so industry are demanding beam time a lot and like to solve their problems at a synchrotron. So in a sense, from a person point of view, we're at the second generation, in that people were already users when they got released to the world. And that's another reason why Africa needs to get involved. Of course, here you see that, Africa will be half the world's youth, and we need to educate this youth. So we need 1 million scientists just to be 1/6 of the average scientist population of the first world. And we don't have that in anywhere near at the moment. So the synchrotron is that instrument that we think will play a huge role in capacity building. And now is a favorite thing of mine. Okay, I want to talk about Africa, that some people think is like a dark continent, and now you see it getting lighter and lighter. It's like, conceptually, we want the African light source. We want it because it will make Africa a full participant science. And I just want to ask now this question: who is Africa? Who? Everyone, I think, in the audience here, you would all be African. Why? So first of all, I could say whoever is African could be someone born in Africa. Or we have Sekazi also in the audience. A lot of science facilities in Africa. We have an African science diaspora. This is huge. So I need to emphasize that all of those groups in African, but he was actually the first democratic president of Africa from Ghana. His name was Kwame Nkrumah. He was quoted by Arikana, but this quote is first attributed to the very first freeing themselves from colonialism. Ghanaian President Kwame Nkrumah, a giant intellect, if you read his work, he said, to be an African, you do not need to be born in Africa. Africa must be born in you. And that is the very, very inclusive nature of when we want to talk now about the African light source. We just want to welcome each and every one in the audience to consider themselves African, and because Africa can be born in your heart. So this picture again is using African science. So you see examples, that some of them are going a bit more detailed, but they capture a medical science, which is African science, and paleo science. Bottom left is an archaeo science. And then top right is all the geoscience, which is beneficiating Africa's mineral wealth. And then the rest is for us all in the whole world. We all want clean energy and new materials and so on. We all want innovation. And this is what we expect to get. And I just included this slide because it's a call to the whole audience to be inspired. It's a song, you could click on it and listen to it in YouTube. It's an African language, and it says Puma Mina, and it translates to send me. is to inspire everyone to contribute to the African light source. What can you do to contribute to the African light source? So it's a song. I think it's like a theme song, if you like, of the African light source. So now I want to get to the history. I just have a picture of the Cosmin Tingwa because we thinking of him as one of the fathers of the African light source, achieving the first formal Pan-African call in writing in the founding documents of the African Laser Center. So that was a long time ago. And then there's been this continent-wide conversation and also global conversation. People in this audience also participated in it, a global conversation. Even before Africa was sticking out as a continent without a synchrotron, it was a global conversation. And then there are the major milestones on the roadmap, of which I think a very important one is the formation of the African Light Source Foundation, which then did very, very many things. And it's got a web page that is essentially africanlightsource.org, and you can go there and see more. And we've done a lot of authoring to chronicle why, when, what, and so on. And you can pick up such papers here. But most importantly, we developed a roadmap, and the roadmap has got parts that are bottom up and parts that are top down. Bottom up parts would be us as a community, that we can do human capacity building, and Africans can access existing light sources, and they can make relationships, networks, global networks, and industry can participate in this, and we can build the community who are African light source users and also do the public outreach. So that all of that doesn't take any special additional budget, and we use mostly existing funding instruments. Then top down, in the beginning, this does not cost a lot because it's political. It's to have the conversations with each and every African government in many, many, many platforms. And here I want to pose the African light source more as an umbrella, which harnesses many other organizations who have the same vision in some way. And then they also participate in triggering all of these continental African government level conversations. Of course, what also will be is this conceptual design report. It's 5 volumes. When we slap it down on the table, when we have it, I just heard it could be later this year we have it. These weighty 5 volumes will make people pause and think that the African light source has really started. So I would like to date things being really serious when we slap this conceptual design report 5 volumes down on the table. And then just, baby steps promoting inter-African cooperation, local and regional level, and you're going to see some of that. And then going towards the African multinational beamline, we are asked now to really think about this. Will it be at Sesame? Will it be at ESRF? Will it be at Diamond or so on? We don't know, but we want to have an African multinational beamline. And from there, we also will look at Pan-African membership or regional African membership. So it's more affordable to us to join the governance of an existing light source. Then you will see the technical design report. And then this is just to show there's many, many conferences, and they've grown. So we had more than 500 last year, and their links are all there. And this is what our conceptual design report will look like. At the bottom is a link to an event, which was one activity in getting the buy-in in the community to help author it. So there are more than 100 people contributing to it at the moment. And the person editing the whole thing is Kazim Tingwa, who is a panelist here at the moment. And then you can read there what the different volumes are about. And we always asked about site. What is the site? And we won't choose the site until well after the conceptual design report. And it will probably be like I experienced the square kilometer array, where no one knew the site of the square kilometer array for a long time. And different countries made bids to be the site of the square kilometer array. And that same process will happen in Africa. And so what we really are just doing is developing requirements that such a site should have. I'll just give you some example requirements there. And I hope that we do choose the site very well. But once we have chosen the site, then we get the technical design report. And here's our rogues gallery of people who have expressed formal support for the African light source, of which I want to particularly highlight Sesame and Lamp. Lamp, I'll say more about. Sesame, I'm sure you know, but these have particularly close relations with African light source and would welcome more organizations to participate there. And now I want to go to some African science and just touch on it. But basically in every field you find excellence. And that's something that I really want to highlight, is the excellence that is in Africa. And often people say, you know, when are you ready to have an African light source? And then there's like a rule of thumb, you must have 300 users who are in a community and who can sustain the use. And Africa passed that long ago. I think one issue we have is it's hard to audit, but when we do audit it, I believe we have that level of excellence and breadth of footprint geographically and in Africa. And we also want to claim, you know, that even the science diaspora still belongs in Africa. And this slide, to explain it to you, there's a fact that everyone believes, but I've never seen it really motivated. And we have to sell the light source to politicians. And as we say this fact, we say, yes, a light source really puts you on the road to drug discovery and really addresses disease with vaccines. That's a fact, okay? But it's very hard to make that connection. So if anyone knows where it's really well written up, we would love to see it. But here is a kind of a collection of where we stand with that for Africa. So we've already mentioned that the synchrotron is like this fantastic microscope that lets you see structure to atomic level, biomolecules, viruses, and so on, and zoom in wherever you need to on pathogens. And then from structure follows function. And in fact, you can match other molecules to the pathogens in such a way that they destroy their function, render them inert, whatever, and then you have a medical intervention. So this is how it goes. And here are 6 papers which actually establish this for, in particular, HIV/AIDS. We could wave goodbye to the HIV/AIDS vaccines if we did not have synchrotrons. Now we saw it even more strongly with COVID. And I don't want to make it sound that simple, because there's a huge step of billions of dollars still to go from the academic knowledge to a drug on the market. And that needs the pharmaceutical industry. But the very, very first step is this that you see on this page here. And I think it's very, very important and needs to be brought out as clearly as possible. But it is in fact brought out in Africa's own research. And this is a success story where high blood pressure, which is very important in South Africa, for example, is treated now with an enzyme that came from synchrotron-based research. And you see the story here where you could make crystals of the biosample that you need to study, and then you could take many pictures with different orientations of the crystal in reciprocal space, do the inverse problem, and find the structure and study the structure, and also study how you're going to deal with it. So this is one of many success stories. So the African bioscientists, I think they clock up 20 to 30 major success stories. This is a water purification system that is also being developed from that same way. And here you see papers where the malaria vaccine has emerged. And you see African authors also on this paper, African institutions. So now there's a malaria vaccine. It's showing great promise, and it's going to absolutely transform life for millions of people. And then here you see the HIV research, and again, African scientists. And I think this is the same. So this is really the same. So you see a great participation of African scientists in biosciences, in macromolecular biology, as they call it. And here's a young person, very eminent. I especially had her in my earlier slide, participating in all of the research that we are talking about in a very important way, showing that I would say Africa is completely ready to have its own facility from the bioscience perspective. But that's not all. These are material science studies of historical documents which come from Timbuktu, where you can look at provenance and study all kinds of aspects of their production. And it's also very important. And of course, it's collaborative. It must be at this stage, but it is closely involving African researchers. And this is the same thing now in rock art, or it's going, I guess, more to the archaeosciences. For me, the most Damascus experience that I've had of science is this field here. Is amazing. You will find something that looks like unassuming rock. And in this case, it came from South Africa. It's got a crack down the middle, but it's not separated. But if you look at this, it could be a rock. And it was lodged in the earth. And I want to give credit to one of the persons who was involved here is Paul Taffaro, and you probably heard of him. He's very famous now. He made the revolution in paleosciences from 3D tomography by X-rays with phase contrast. With so then if you look inside with a medical CT scanner, there's something in there, but you see that it's not very clear. And when you go to phase contrast tomography, there's very definitely interesting things going on. Now, that's just a slice, okay? It's a tomography, so that's just a slice. You actually have that in 3D. So there are two creatures, one essentially mammalian and the other reptilian, and they're inhabiting the same burrow. So there's obviously a story here with detective work that can be done. There's damage to the one skeleton, and it's thought that the more mammalian one wanted to recover and crept in to the burrow of the reptilian one and shared it for warmth, knowing that the other one won't wake up for 6 months, and then got sealed in there by maybe some weather event or something like that. But you can see the clarity of the image. So this I found incredible. There you see it. And so many papers have come from this. So many African authors are involved, and many papers zooming into different aspects that you see here. And here's a very interesting one, which I really want to show because the culture of paleontologists is dramatically different now. It's normal, I think, in the past that paleontologists were made or broken by whether they did or didn't discover a fossil, and then they jealously guarded their fossil and didn't let other people see it, and it would be their lifetime's work to examine that fossil. And here you see completely the opposite happened. This is a paleontologist, Lee Berger, and discovered this fossil, and literally within days it was on the president's desk, getting a special dispensation to go to synchrotron. And it shows you the transformation that's happened in the discipline. Do not hollow out the brain cavity yourself. Do it digitally, have a 3D extraction, and do your paleontology like that. That's a very remarkable thing. And I just want to say it's caught on in Africa. So this is a footprint of paleontology with African scientists at synchrotrons, and you see a large coverage of the continent. And then South Africa became an associate member of the ESRF. The South African community chairs Tsepo Ntswane, maybe in the audience, I can't see. And he's guiding the South African community on the path to greater and greater use of synchrotrons as a tool for science. And I think it's very important. We've had the third renewal, which is expensive for us. And our aim now is to broaden the footprint in further countries of which our government has committed itself to do that, and find amongst our neighbors or more distant countries who would participate in the same way. And this is a couple of slides presenting the synchrotron to the African Union. It must be clear that the African Union can't say, let's have a synchrotron. It has to come from African governments. They could then declare it at the African Union, and then it could become an important thing articulated by the African Union. And these are steps along that way that chronicle the importance of a synchrotron in print documents of the African Union. So it's a kind of science diplomacy that's already happening. And here I would say that it's both the African Light Source and the African Academy of Science who are punting it at this level. And so those were examples there. And now you may ask, how are we doing with African governments? And there's been two reiterations of Ghana that it will champion the African light source. By champion does not mean they will be the site. It means that they will push it at government level. And then also very, very strongly from Benin, they've made a facility called Xtech Lab. We'll show you a little bit more about it. And that is a regional facility, in fact, and it raises the bar in the whole region for using X-rays in this way. South Africa also, I've just mentioned, they've afforded the scientific associateship to ESRF, but they're also looking at it becoming the next flagship project. So life after SKA, if you may put it like that. And then some other countries as well are putting their shoulder to the wheel. And this is a fascinating event that we held, and we see about 5 African governments and the Africa Union Commission represented here, and being chaired by the person who triggered the founding of the SALT telescope and the early SKA, and we call it the Ministers Forum of Africa, and we broaden it each year. And then I want to point out many Pan-African scholarly associations. They can be sometimes regional or national, but often they Pan-African. You can cast your eye down the list and see African this, African that. And so these are, if I may say, partners for us who add their voice that there should be an African light source. And here I wanted to highlight directors of synchrotrons, and we have enormous support from many synchrotrons at director level, of course all levels, but also up to director level. And so I think it's fantastic how we feel the strong friendship from the international community. Now, I spoke about regional facilities and we developing those. So here you see several mentioned. So there's the ICTP Center in Rwanda. It is the African Laser Center. There's the Sir Oren Klug Center. There's Xtech Lab that I mentioned before. And then even other institutions putting their minds to it. And this is the vice presidents and so on of African universities. And this is a collective footprint of synchrotron use in Africa. And this is an example of African industry here making it to the front page at one stage of ESRF's newsletter. But you will also see the footprint of that industry in the world and their deep use of synchrotrons in developing their catalysts. This is placing markers on a map where there is capacity that we have known of that could do the level of bioscience that I've been speaking about with drug discovery. And this is markers where there are large facilities that we know of, which could be feeder facilities, research facilities in their own life, but also feeder facilities, of which I mostly want to draw your attention to the IUCR's Open Lab, founding so many of them throughout Africa. And what's remarkable here is the Xtech Lab being presented by Thierry de Almeida, who led this, and this is the cabinet of the government of Benin at that level. And who want to say they explicitly in their documents see Xtech Lab at Semi-City, a kind of a smart city, for as a regional facility to develop in the region of hundreds of young masters and PhD students. This is a similar thing for the Oren Klug Center in Cape Town. this is one of the launchings of an open labs facility that I mentioned before. And now this is this LAMP, light sources for Africa, the Americas, Asia, and Middle East, and now the P is the Pacific. And involved in training, mobility, networking, local facilities, and conferences, and partnering also with the African Light Source in this. This is a recent workshop that we held together earlier this month, and it was to broaden the footprint of applications for their training program. And this is bears special mention is a fantastic program that the Diamond Synchrotron launched, but was co-funded between Africa and Diamond, and it produced a large number of highly trained young people. The tragedy is not many of them could get employment in Africa, so we fed the science diaspora, but it was incredible how many people got trained and the quality of science that happened. Here now, I think is a slide that doubled up, but such things that I've shown you with START are happening in many other synchrotrons. And here's an example of young people being deep trained in ESRF. And the number of events, they literally become too much to mention. So here's a side event on the AFLS at the IAEA. and then again, I touch on our conferences. We have an international advisory committee. You see a who's who. Only the members of the international advisory committee are mentioned in blue, but you will see there, I'll just mention a few. Rolf Hoyer, who's president of Sesame, former DG of CERN, is there, and Francesco Sette, who's director general of ESRF, and so on. You see from the IEA, one of the directors of a division there. You see Melissa Denneker, and so on. Jim Gates, who's the president of the American Physical Society, and so on. So you see some other directors of synchrotron facilities and a Nobel Prize winner. So this is a very top level international advisory committee. So here I just emphasize again the biophysics aspect. I think it's a very special aspect for the African continent, and mention again all the different initiatives that we have in this. And then you will see them mapped out onto many events. These are 2022 and 2021 events. There isn't time to tell you them all, and I don't even think they all captured. Now, sometimes people ask, how can they participate as well? And so we want to develop a African virtual university on light source-based science. We still in the stage of understanding how this could come about. We have a Pan-African University in Africa. It's called the Pan-African University. And so it's a logical place to place such a thing. And in the beginning, we could benefit by excellent MOOCs or similar courses around the world. There could be some sharing aspect like that. And so we're very much in the proposal stage, talking to stakeholders and seeing how we could do this. But we would like to have a light source-based science, which could train Africa. And here I advertise our next upcoming conference. So this is the link. And just summarize again the key things from the international community that would like to do. So this 1, 2, 3, 4, 5, those are all things that we could partner with the international community in doing. And I think the one would be the Africa Regional Beamline and the Africa Regional Membership. And then again, with international light sources, a list of 9 things that we could do. And you can see, again, it involves partnerships. I think the best partnerships would be deep training ones where we could have students and postdocs and young staff members and so on for extended visits in some kind of sandwich way, to not necessarily staying abroad for longer than 12 months, but maybe in stages, so that we kept a strong linkage between the partnering university and the African university. And I want to end with this slide, as I think all the young people in the audience, can you see yourself here? Can you see yourself learning about a synchrotron, being a future leader for us? So it will be your African light source, and we'll need you to connect to us, connect to the African light source, and be a recipient of training and funding for projects, so that you can be a future leader in the African light source. So my question is, young scientists, can you see yourself here? Thank you very much. And I'll stop here.
Thank you very much, Simon. A very exciting presentation of what can happen in Africa, and also all those different projects, so that you brought as well to the attention of our audience. It's very important. And we have the chance as well today to have actually 2 APS presidents with us. So you can recognize their Jim that you had before. And Laura Green is as well with us, so potentially to speak. So thanks a lot for this complete presentation, looking at how as well it can empower, bringing capacity for industry, for all the educational world as well. So I think that now we will have time for a few questions. So maybe from the audience, and then we have one in the questions session, question and answer. So maybe I can read this one first. From Sema Azeram, so asking, it's related in the sense of the different possibility for having access as well to software and computational work. So you were speaking about this university, for instance, so connected to that, will it be a possibility as well for sharing such type of software and computation?
Yeah, so I would like Semang Azemare, please contact the African Light Source. You can get it on the website, or you can Google me, but we definitely will connect you with resources. This is something very, very easy to share, remote use, and actually from many light source facilities in every country, we've had offers that this computational work and software access is something we can arrange, absolutely. So please connect to us, and you probably also will need, I'm not sure how expert you are, but if you need tuition in doing that, then we also will be able to help there. So please connect. That's all you need to do.
So that's a very good answer. So maybe from so Sekazi, is it some complement as well that you can bring from the African Light Source, the CDR, all those aspects of what are the challenges as well, and what are the different deadlines?
Sure. Thank you so much, Christine, for inviting us to come and make some comments. I think the most important thing, since Simon has done such a great job of laying out the framework of the history and what's happening, is to encourage young people in developing countries, and specifically Africa, to take advantage of lots of training opportunities. I mean, if we have this light source in Africa, we need people to use it. And so it behooves us to encourage, faculty and students who don't have the training to in fact do it. I mean, Simon mentioned the LAMP program. Please, I'll put it in the chat as soon as I finish talking, but LAMP has opportunities to send faculty and students to light sources for 2 months to train and get experience, and to send them back the following year for 2 months. I mean, to date, we've sent about 100 grantees to the facilities for training. And so please take advantage of that. There's funding for it. LAMP, one of the things LAMP did was to work with the government of Benin to start the Xtech Lab that Simon mentioned. So with Xtech Lab, I mean, we train students in the art of crystallography. And thanks to the government of Benin and the French embassy, the training is completely free of charge. And so we're planning in November to bring 20 people to Benin for training. Please apply for that, because the applications, the call will go out on, I'm told, Friday. So that's something that is certainly available. Another source of funding, Simon mentioned the African Laser Center. This is an organization that we founded back in 2003. It's hard to believe that it's been almost 20 years. Time really flies. But I mean, this organization provides funding for research having to do with laser, the applications and use of lasers. So please, that call for application went out maybe a couple of weeks ago. And the deadline is not yet over. I think it probably won't come up until November. So, if you have, a laboratory that, needs laser equipment or travel funds, please look into that. I mean, this is an example of the type of feeder facilities that will be necessary for an African light source, because when you show up at a light source, you need to show up with your sample, with your crystals or whatever it is you want to study. And so you need to have your local facility up and operational. So that's extremely important. And finally, I'd like to mention we have training programs. We offer synchrotron schools. We had one last year that was led by the International Atomic Energy Agency, LAMP, University of Johannesburg, ICTP, African Light Source, and we've been approved to host another synchrotron school. And so this will be coming up probably early in the year 2023. So if you're not familiar with light sources, this is an excellent opportunity to get sort of an overall perspective on what these things have to offer. So with that, I think I will stop, and to again, thank you, Christine, je vous remercie beaucoup for all of the hard work that you do, and for Simon leading the charge. Joe, hanging in there, pushing us further. Simon, Herman is our sage. He's our leader. He has mentored me and so many others of us. So thank you so much. And Jim, of course, is a great friend for many, many years. I hate to count those years. And Laura is a recent friend. So thank you very much.
Thank you so much. So it was very complimentary. And as well, I will get the opportunity to mention those MOOC as well. So indeed, it's for the science aspect, but for building accelerator as well. And we have as well connected those different type of capacity for massive open online courses, which everyone can also access for free. And this is, I think, the opportunity to build up as well more knowledge in Africa. As you said, the 300 users as the critical mass, but much more than that for the operation as well. And it was really good that you bring as well the perspective as well on how in Brazil everything has been done as well with the support of the industry. So this is really the way to boost those capacity. So it's very nice to see that.
I just ask you, Christine, because you mentioned your MOOC. MOOCs, which we also advertise on our website. But one of the things is we want young Africans to go away with a degree, not just a certificate that they attended with a MOOC. So we want to accredit the available resource for teaching within the African countries with partner universities. And so that's what we're really asking the international community. Is there any chance to present them in such a way that although you've got these MOOCs and they are already set up, but could package them into a course where they make sense in terms of credits and a sensible degree, then students can actually do them with a collection of others and have not just a certificate that they intended a MOOC, but have a coherent degree on some level, master's, honors, who knows, graduate level.
Graduate level, and the one we had was more for undergraduate in one sense. So this is why it's more like massive in that sense. But it's so important as well that this is done in situ as well in Africa, looking at the societal challenge of Africa. And then one of the question potentially as well for Kuda. So we have him as well from DSRF, so connecting, and there was a lot, as you show, of fantastic pictures as well and motivating animation as well that could be so interesting as well for and to motivate the African Light. So I know that Kuda was working as well on those different paleontology aspects. So maybe Kuda, do you think that in terms of what would you recommend actually for the next or the first beamline, something complementary to tomography or something which is maybe an advantage for what cannot be transported out of Africa?
So thank you very much, Christine, for allowing me to say something. I have actually, it's something that I was thinking about recently, and I was thinking maybe something where if we're going to have a beamline, which will be used mainly for people to gain expertise, who are going to work in the future in African Light Source. We would want something where we have a multiple number of techniques. So we would want to have a tomography stage at one point, because we could probably look at what are the probably most of the users from Africa, which fields are they coming from? Definitely we would want something on diffraction, so we can have a goniometer maybe at the end of the stream, and we could also develop, because there is the instrumentation side, so we could have people who are working on the X-ray optics and doing research on something like I know there's a research on speckle tracking at the moment and stuff like that. So this is what I think, a one beamline, probably a little bit of a longer beamline, but with a lot of different components. Hopefully, it can be at one of the fourth generation synchrotrons, since many are coming up at the moment. It might be possible to get one.
Yeah, I think it was really good. And we have a question from Jim then.
Yes.
Comment, maybe. And you are muted.
Thank you for the opportunity to join this group. I'd like to, of course, salute both Herman as well as Simon for that excellent presentation, which I was sitting here enjoying in the background. I had not expected to be part of this panel, but your flexibility, Christine, allowed that to suddenly happen. Let me apologize for the dark glasses. I have some issues going on with my eyes right now, so I have to avoid bright lights, and that's why I'm looking rather mysterious today behind these dark glasses. They're totally an accident. And what I wanted to do was, first of all, to make the audience aware that the American Physical Society is very, very supportive of efforts to address development of physics on the African continent. There's one rather interesting opportunity that I'd like to put in front of people. There's a program that the American Physical Society supports called the Innovation Fund. And the Innovation Fund provides two rather small but 2-year grants that you can sort of think of as starter grants. And this program has in fact supported the U.S. Africa Initiative in Electronic Structures. There was an award made in 2019, and our colleague Omalu Akin Ojo, the director of the ICTV East African Center for Fundamental Research and the international counselor and an international counselor for the APS, has noted this. So in order to apply for these grants, any APS member can make a grant application. So if there are people in the audience who know people who know other individuals, research scientists, interested parties that can think of an innovative program and they need a small starter grant and perhaps get it off the ground, the application can be made to the American Physical Society by the member, partnering with external persons. And these grants, as I said, are relatively small, but they might be exactly what's needed to launch something very large. So I just want to put that in front of the audience to make them know aware that this possibility exists.
Thanks. We'll follow that up. Thank you. We noted.
Thanks a lot. And then maybe it's an opportunity as well for Laura, if you want to add as well more for the synergy or potentially as well for the scientific case that could be interesting between America and Africa. Indeed, there are much lesson with Europe as we see. So there might be as well some of the reason behind, but because there is a growing interest as well for the American or for the diaspora to connect more with Africa, I think it could be interesting to see how or what, in addition to what Jim said, could be thought about.
Well, thank you for bringing me on as a panelist. I planned on just learning because, you know, when I see Herman and Sakazi here and Joe, I'm just really impressed to be in this group here. Well, I guess as Joe knows and Sakazi knows is that I've been involved with IUPAP for a long time, and all I can do in my role of IUPAP is just support all the work that's going on there. And it is very important. You know, people argue, why do you need another light source? Well, there's a lot of good reasons, and they were extremely well outlined by Simon. This was just a tremendous webinar, and I really appreciate being part of it. I don't know, when you talk about as far as bringing in Americans specifically, that's something I think we'd have to just advertise and try to do that. Right now, Florida State University is working on twinning with Ukrainian universities, and you want to do this and be careful not to brain drain and support. And maybe we can find a way to have other universities just be more aware of the opportunities so they can go to the African Light Source and just interact and create partnerships. Because the US right now, even though we have very serious barriers to international partnerships, the present administration is very supportive of domestic and international partnerships. And this may be an opportune time to start building those partnerships, and maybe through the people on this panel, we can just put together a group of academics that would want to interact through seminars and building up other partnerships for you know, short-term interactions and longer-term goals as different countries get stronger and stronger in their science. So that's what we're trying to do. And one of the things we brought up is that being in Florida, we're used to recovering from disasters. So maybe we could lend a hand with Ukraine. So
I just wanted to add that earlier this month, we had a meeting with the NSF and the DOE at very high level, and all the facility directors for light source science in America. We had the very, very big meeting, and we mapped out a whole set of points that could lead to collaboration and partnerships and so on. And we've just shared that amongst each other, and I think it was a kickoff meeting, and we'll have a follow-up, and we'll want to include those kind of things that you've just mentioned. And so I'm hoping that it will be the start of a deeper conversation and actual projects where the USA can increase its visibility in promoting the light source in Africa, participating in that.
That's terrific. Now we need to have some high magnetic field work in the beamlines, but so no, I didn't know you had done that. That's really tremendous, Simon.
Yeah.
Thank you.
Yes, that's wonderful to have those opportunities. So maybe Jim will add the solution even more in a shorter time.
Christine, may I have the floor?
Sure, go ahead. Yes, please.
I wanted to compliment Simon, especially on the timeline. This push to get a beamline in Africa, a synchrotron beamline, as outlined, it has been a sustained effort. In fact, in the 2004-2005 period, as Simon well knows, there was a report in South Africa called Shaping the Future of Physics in South Africa. And that report highlighted the benefits of a large national project and a type of project. One was an SKA type of project, but another high priority was in fact a synchrotron. So this is a sustained effort now, as Sakazi mentions, over 20 years, and it has been building in intensity. And I'm hoping to see that the breaking of the wave, so to speak, where we can see a dirt turn someplace on the African continent, for there to at last be built a synchrotron source available to the people of the continent, and which would be a gateway for all the incredible talent that all of us have seen by visiting the continent on a number of occasions. So the potentiality is definitely there.
Thank you.
Thanks a lot. And indeed, the vision as well of using or developing synchrotron for as well a common cause and for this human right aspect. So, and I know that we have some Ukrainian as well in the audience. So Laura, I think it was really important what you was just mentioning of all the effort with the APS. And as well, we have some Canadians. So I know that Mark Boland is also listening. I know that the chat was disabled, so sorry for that. So would we have maybe with Herman, because you are as well looking at the ambassador, like Jim has been as well with the ASP. So this is how we had this name as well for you, especially James, for the first ASP. So in South Africa. So, but looking at all the material and maybe those multiband achromats. So maybe you can give some advice as well, looking at what to do and what not to do for the African light source, Herman. So would you want to take the last words and last hope for the peaceful aspect of it? You are still muted, so sorry. Yes.
Hi, can you hear me?
Yes.
Yeah.
That.
Okay. I think this was an outstanding talk. The most important thing I'd like to emphasize is that the recording of this talk should be available on the African Light Source website and broadly inform people. I know I can distribute it in many ways here at Stanford and elsewhere in the US and around the world. Simon deserves an immense amount of credit for putting together all the various benefits of the light source. The only other thing I would add is to emphasize the fourth generation nature of the present situation, where we now have had a breakthrough in conceptual design of light sources, leading to not only significantly higher performance, but lower cost, because ways have been found to develop magnet lattices, these multi-bent achromats that make smaller beams. Smaller beams require smaller magnets. Smaller magnets are less costly, so that you can make a storage ring now, which would produce electron beams or circulate electron beams much brighter than any existing light source with small magnets. It may be a larger circumference, but the main cost of the magnets has to do with the cross-section of the magnets. And if the aperture is reduced, the vacuum chamber is smaller, the cross-section of the magnets are smaller, the cost is smaller. So it's a remarkable situation which we can take advantage of right now as advantages being taken of these new concepts by improvements in many light sources. The ESRF, the Advanced Photon Source in the United States, Japanese machines are being stopped, removed, and a completely new magnet lattice is being put in for a new machine, which much higher performance at very low cost. So it's a unique opportunity to jump in and take advantage of this breakthrough in accelerated technology. Anyway, I want to thank Simon for this excellent talk. I look forward to being able to share it by sending a link to my colleagues and friends throughout the US and elsewhere. And to thank Christine, Sakazi, and others for all they've done to promote this light source in Africa. Thank you.
Thank you very much, Herman. I just maybe we'll read as well in the chat. We have question and answer.
Could I make one comment before we
Yes.
go on? You know, one of the big impediments I think we are going to encounter is the lack of English proficiency. And I'll give you an example. I just a couple of weeks ago participated in a conference, the 4th conference of the Union of Physicists from Portuguese-speaking countries. And so we had representatives from Angola, Mozambique, Cape Verde, and I just could not talk to some of the students because they did not speak English. And so I beat this drum a lot when I'm meeting in Africa. All the students must learn English because English is the international language of science, business, government, commerce, everything. And I tell the students, at least I made the comment that, in the audience, we had many from Brazil, Portugal, and elsewhere. All of the Portuguese spoke English. So why don't, so the Portuguese speaking African countries have to speak English. So I want to just lay that down as one thing that we really have to solve.
I would say they could survive with French as well, isn't it, Sekazi? In Africa.
Yeah, I attended a conference many years ago, not that many years ago, in Benin, and I can speak some French, so I can survive, but I couldn't get into the nuances that I wanted to with the students. So again, I think you really do have to speak English. You speak English, Christine.
Well, with an accent, but at least try to communicate. Yeah. Yeah, so thanks a lot. So that was good, very good comment. So indeed, so Simon, just also from Cheryl Spencer as well, who was mentioning and hoping that this light source as well will not be used for military tasks. So can you just confirm that? I think it's important. Yeah. We were speaking about peace, and she has also been very involved with the science, the physics for society with the APS, and has been as well in the FIP, so one of our former president. And then there's a last question as well, which I think is also very important and pertinent for Peter Gins, looking at the connection and the role with the African government as well, and especially for the private sector in ensuring the realization of the African light source as well. The support is crucial. So can you maybe give example or complement what you already mentioned briefly?
Well, we're trying really hard, and we are speaking to some governments in Africa, and they're opening the doors to the conversation to others. And I don't want to suggest we're the only ones. I showed you a long list of organizations, and so there's a lot of voices. And I think the momentum is growing, and I really wanted to emphasize that COVID, it really showed that Africa needs its own research on drug discovery, and that was just one aspect. So I think it's happening. I think it's growing, the government interaction. So I think that there was some of that in the slides. And also when it comes to the industry, we the two, actually there's been three. There's been energy industry looking at turbine blades that I know of, and the oil from coal industry looking at catalysis, and then there's also been work, just general material science, which really has close connections to industry. So those are the ones I know of, and I think there's going to be more. So definitely Africa will be represented, but it's something that must be like growing, you know. So I take your point, Peter.
I think he cannot write, I guess, in the chat, but he's thanking you. And thanks a lot. So I think it's about time. So with all this time. So Herman, so you have one comment, please go ahead. You have to unmute. Again, sorry. Yeah.
I'd like to add just a comment on the comment about industry interest. One of the major activities at Stanford and many other labs is using synchrotron radiation for battery technology. With the thrust that we now have for electric vehicles and batteries operating so many different things, experts in the field believe that we are on the cusp of making improvements, orders of magnitude improvements of the capacity, size, lifetime in terms of the number of charges a battery can make, by understanding the mechanisms by which a battery fails. And to do that, you need to have a microscopic understanding of the developments at the cathodes in particular, and work out improvements. So this is going on, and there's a lot of encouragement by the people who are doing this, that we will have batteries very soon that will have an order of magnitude more capacity, lifetime, etc. I think that's going to be very important.
Indeed, and without cobalt as well. That's the important aspect. Indeed, and as well with DSS, we will try as well to do some research with neutron, so to complement as well the photon world. That's important, this energies. So I will maybe close this. Any final comments, Simon, or I will just show what will happen next month?
No, I just would like to give my thanks to the audience and the panelists, and to you, APS. It's a wonderful series, and thank you for participating.
So thank you a lot. Thanks a lot, Simon. So I will just share my screen and show you that next month. So we'll have on the 27th of October, so the possibility to listen to Professor Kate Shaw. So speaking about as well the physics without borders, so without frontier. So physics for development and international cooperation. So that's going to be on the 27th of October, a Thursday, like the last Thursdays of the month, at 10 a.m. in America, looking at EDT, but for us it's still 4 p.m. in Europe. In South Africa, it will be as well at 4 p.m. So I guess there is no change of the timeline at that time. So she's also involved with Atlas, like Simon, and also and mainly with Joe from the ICTP as well. So she's the co-organizer as well of the Physics Without Borders. So we are really happy to have her so next month as well among us. And in the meantime, so with Joe, maybe any audition comments, or can I close then the session? Mr. ICTP, he is frozen. No, he's there. Yeah. So I think it's okay. So we will then close on that. So thanks a lot to everyone, and thanks a lot for all your ideas. I think we have put as well quite a few plan as well for a soon future, hopefully. So action item, and we will follow up on that. So let's stay tuned. Thanks a lot. Thank you, everyone.
Bye-bye.
Bye-bye.